Good morning. So my name is Pedro Candel. I come from CyberSOC Academy from Deloitte, and will give you some introductory concepts to follow my presentation. So first of all, I would start by sharing with you. Well, first of all, let me apologize because this presentation is in English. And as Antonio very well said, we really need to have a good understanding of English. That will help us out a lot. So a covered channel is the definition that we have for it. It says on the screen, and it is something that we can use. We've been using covered channels through traditional means to communicate camouflaged information and also transferring information about system with an effect on the system load. So we will see whether we will manage to recover, to discover ROM or not. Tempest is built by the NSA, and it is also a certification, NATO certification. And what is it about? It is about espionage, about information system, and it is about also leaking emanations, including unintentional radio, electrical signals, sounds, and vibration. So Tempest covers everything, and it also tells us how to shield, how to protect our equipment against spying. And here we are talking about all the industry standards, such as EMSEC and other ones. And this is just we have ComSec, which is often referred to as MSEC. Well, this is about a TDRR, and nowadays the NSA, our friends, are saying, well, I do it myself, I shield myself, and I'm going to classify it, but I'm going to give you these things so that everyone follows us and everyone do whatever we do. And they said, okay, I'm going to tell you what you have to do and how you will have to shield your equipment, the distance that you should have in between your systems, so the distance from the wall, the type of cables that we have to use, shielding, etc. Basically, here we have the sound dimension, and here we have mechanical vibrations, and technically we also heard about the possibility to have mobile sensors to recover everything that has been written. I've seen something in that regard, but I haven't seen it in full operation. So, Tempest Attacks. It is an attack which is based on a principle of electromagnetic radiation during a normal use. Any type of device, whether it is a fax machine, we have them out there with the correct equipment, such as antennas, receivers, display units. In theory, I'm saying in theory because there is some security in place. In theory, from a remote location, we could try and see those signals and to reconstruct the original signal. If I am working with a CPU and if I am transmitting zeros and ones, and if that is radiated to the spectrum, perhaps we could end up receiving that remotely and to get at the original signals. And imagine that if this were possible, how it could be misused to violate your privacy. Well, the equipment is emanating these signals and is radiating all this. This is implicit. This is not nothing strange. We shouldn't be paranoid about that. It is quite a complex attack to reproduce, to carry out. But in theory, as I said, it could be possible. We cannot really end up like these people here wearing these hats so that they do not take our brainwaves, and so that they just cannot follow our thoughts. This is an attack in principle that cannot be detected because it is a passive attack. And as I say, we are radiating radiations, and as I say, from a remote location, we should try to reconstruct, we could try and reconstruct that signal, and we could do that from any point. And the problem here is that any electronic device emits to a higher or lower extent electromagnetic radiation on an ongoing basis. And actually, the CPU is radiating the highest level of electromagnetic radiation. I'm not going to go into voltage here, and we are just tell you that we are generating electromagnetic pulses that radiate, and actually the standard is telling us to shield our equipment. For instance, there are stickers, CE conformity, adhesive stick, adhesive, and then this is being copied by the Chinese and that they put in their fake equipment. So this is the circuit. Here we have a circuit board. We have here we see the actual radiation from the actual bus, and then we have all these cables, and here we see gaps in between the circuit board, the chassis, all that could be because it has radiation, it could be subject to an attack. Is that a myth or a reality? So let us see what could happen if we have a middle of the night attack. That is to say, someone who from any location enters your home or your office, it just displays a big antenna, brings out a big antenna, and then reconstruct our signals and end up knowing what we are doing. Is that true or not? Well, I decided to demystify this, and I said, okay, I'm going to put myself in the shoes of these people and see whether this is a myth or a reality. The first thing that I found was an email from the 18th of August 1999. We are in 2016, nearly finishing, and here notice that that was already written in 1999, and that person took the source code in C and that used the monitor, the big monitors at the time, that it helped transmit a song that was received in a device such as that on the screen. So here there is lots of young talent, and perhaps you don't know what that is. That is a traditional radio. We had cassette tapes at the time. Well, that device had tracks in it, melodies in it, and it also had that capabilities. So today we have the Raspberry Pi, and it could become an FM transmitter. This is one of the projects. And the problem here, imagine that we want to exfiltrate data from a device. We have to go there with our Raspberry Pi and then to set up all that, the infrastructure to take out that radiation. Well, also recent projects. This year we had the
We had this filtration attack from 11th of August 2016, and actually here we see the noise generated by the hard disk. You can use that noise, you can take it, you can use it to exfiltrate data, and it has been proven that you can do it. And then also you can also use fans for that. The very same people decided that they wanted to transmit information. Well, we know that fans are all the time rotating, or perhaps when you are doing specific operation, the fan does not rotate as much. That movement is being analyzed in every remote, on every remote equipment, and apparently you can exfiltrate data from that. And now let us talk about Tempest OSX. This is a new channel, a new cover channel, and we have a project. This is not my project, this is the starting point, and it called my attention. These people said, well, they just transmitted on radio with no specialized hardware, just with the circuit board. And I started to take a look at it, and when I went deeper into it and I could see what they were doing, this is what I found. This is basically about running instructions on the computer that will cause the electromagnetic radiation. We want the equipment to do that for us. And how do you do that? Well, actually by sending out sheets to the CPU. So we are not sending anything meaningful or nice. We just sent out a huge number of zeros and ones, and we try just to trigger something. And for that, the actual Intel, here we can see number of instructions, string with 31, with 32, 28. These are not the only ones, because here it does not allow you to do it. And therefore, when you research into it, you find out that we could transmit information via a radio carrier wave. I'm not going to focus on this very much, just to tell you that in that case we should look at how to transmit it. This is the way they did it. And for instance, we threw the string that causes a significant or strong signal. This is not the only one signal, and we can increase the intensity of it. This is the radio electric spectrum, and in principle, well, we decide to stick to the mid-wave. Why that? Why mid-wave? Well, probably none of us is carrying a radio in the pocket. If we carry a radio has FM, and basically this is some of the code that is being used for it, calculated 4 times to calculate this and that. Then when you fine-tune it, you can end up doing good amount of things. And here let us talk about Morse code. Morse code, we have it there, and that will help us transmit a message in Morse. And this time we will take advantage. We will use the dot, the slash, space, etc., etc., and we will try to use it to make the most out of it. Morse code. We have all these characters, these ordinary characters, and then the numbers from 1 to 0. What typical thing, I'm sure everyone has talked about SOS, 3 dots, O, 3 slashes. That would be enough for us to come close to it to see how it works. Well, I need this switch screen. So this is the source code. That's where we define the length, the instructions, the logo, which is an octopus because it hides itself. And this is the alphabet that we will be using. We will be using from letter A, the dot, the slash, logo type. Okay, and see if it works. This is transmitter. I will compile it. This is immediate. We will run it. Well, I lost the logo. Well, logo looks nice. So imagine that you want to transmit instead of SOS. Imagine that I want to transmit the following message. Hello there, or hello people, or cracks at CyberCamp. Imagine that this is the message that I want to transmit. You cannot see it, but well, the device is not logged on to anywhere, and now I need a receptor. If it is going to radiate Morse, I need to listen to it somewhere. So I always ask the same question. Who has a radio, an old radio with him? Oh, sorry, I am being blinded by all these lights. So no one is carrying a radio set on them? Alright, so no one. So therefore I will tell you how you should tune it. So this is a radio set. This is just a traditional and ordinary radio set, and it has AM, FM, has an antenna, and had this knob here for tuning in the channel, and this other one for volume. This is FM and this is AM. So here you can see the letters. That's the bus of CPU, amplification, harmonics, etc. Standard Morse code. So we are listening to the dots, to the slashes, and the device is not logged on to anywhere. This is okay, but it's good, well, from the technical viewpoint. But what is the problem? The problem that we will have. Well, apologies for these technical details. As I was saying, we have a problem. I have a broadcast transmission. Anyone with a radio set? Well, let me tell you that this is not a big emitter. It is very much limited by distance. But if you are close enough to it, you can hear it. And if I send out an A later, you will hear dot slash. And you will perfectly understand, you will perfectly hear that point and that slash. And now we need to have a person or a machine able to understand Morse code. Then I also have a huge problem with binary files. Imagine that I want to take a binary file and then Morse code. I only have from A to Z and then from 0 to 9. And what I'm going to do with the rest of the characters, those characters that, different characters that are within binary code. And all that is limited by the set of characters that I'm using. So therefore, let us try to fix those problems. First of all, we can play with the speed of transmission. We want it to be variable, but what would I get out of it? Well, my test was very slow so that you could follow it, so that we could understand that it was dot slash or whatever, but I could also play around with the variable speed. Sometimes we use the CTFs to see what type of things people are playing around with, and the best thing is just to install, to have a CTF wherever we had our Morse message, and to pick up the signals and then to find out about the transmission speed of the machine. As you can see, but this is logical. We have a variable speed in words per minute. We have the dot length, the optimum bandwidth that we need. Therefore, we can start playing around with it, with the programs and with the automatic receptors and the receivers that we use. And same as when we were with our walkie-talkies, and then we said, okay, it is good that I am getting your Morse message, and we could play around with that. And then also for exfiltrating data from equipment, we could do something like this. I have to transmit something that only the receiver of the information will understand, even if anyone intercepts that message, if there is an interception of the message. And we learned the lesson. We learned the lesson many times. We learned it, unfortunately, from ransomware. What are we going to take and what are we going to do with it? In the receiver of the information, I'm going to play with cryptography, with public keys and with private keys. First of all, I'm going to create a Tempest, and I'm going to extract the public key, and the private one will be kept in the receptor, and then I'm going to generate a random password that could be, for instance, I don't know, 1BV, and then I'm going to encrypt the files with this password, and I'm going to do it with AES 256 CBC for a very simple reason, because we need an encryption that can be reversed. Then if I recover the IV, that is to say the password that I randomly generated, I'm going to reverse it by the time I have it on the receiver. Then that IV together with that public key file, I'm going to encrypt it with an RSA 1496, and last I'm going to encode files on base 64. I'm going to change them to base 64, and last I'm going to normalize it so that I can't emit in or broadcast in Morse code. The problem here is that I cannot transmit it all because I have uppercase, lowercase characters, I have digits, and then I have base 64 alphabet plus the slashes. Therefore, what should we do here? Well, out of what we have or out of what we don't have, well, we should try to get it. For that, we can use the international Morse code. And here we see some punctuation marks, some signs, and here we will normalize them. So here, when we normalize, we substitute. When we want to change from upper to lower, the only thing that we do is just to insert to colon, and last we will be transmitting that. So, for instance, if I find plus, I'll replace it with minus or an apostrophe as I need it for an interfile space. So, and that allows you to play with all that. But because this would be quite complex, doing all that manually is quite complex. So we just build a utility. So this utility will generate tempests, customized tempests. We go here, you want to generate a new tempest, and the CyberCamp 2016, that's the name you give to it, and it has generated the RSA public key, private key. If I don't trust this utility, and if I want to generate it with something else, I take my OpenSSL and automatically I paste it here. It's going to ask me about the file of files that I want to take away with me. And this is, well, a typical thing is ATC/password. And sometimes you need to escalate privileges in the destination machine because you cannot gain access to some files. Therefore, here we could add some exploits. And in principle, well, the exploit side you just don't see, but there are some exploits there. And you can say, I like this one, or I copy and paste it there. Then words per minute that you want to transmit, and then the tone, and then you can also check polymorphic just in case there is some kind of detection because of the IV. We are following instruction of the CPU. Surely no antivirus will detect it. So once we have it, we just click on generate, and then we get a tempest with an ID 6A, 9AB, etc. And here we have some exploits that we could add. That's it. And then we also have that other hidden part, that part that we don't see. Now I will take a look at the tempests that have been generated. This is the last CyberCamp, ATC, pass WD, and it will introduce a number of acceleration, decelerations, and then the receiver takes a look at that and manages that. And this is the frequency of transmission, whether it has exploits in it or not. And here I have the binaries. I have generated a tempest for the remote equipment. Then here I can take a look at what I did step by step, what I did to encrypt
the normalize of the receiver. The receiver is unique. In this case, even if I generate this Tempest is unique for a very simple reason, because it can only encode the signals that I have received, and it can only decrypt or decipher it with this private key. We have the source code now, and the source code, my apologies, okay, for, well, this is not a good visualization. Well, again, we have better Octopus. I know that it has more code to it than that. We have RSA, base 64, 256, then instructions, and this is where I see it hard-coded. I don't mind if the public key is hard-coded of the evil guy that will be stealing things from me. So this is everything that goes with it up until it gets the file and transmits it. So this,
yo lo que voy a hacer va a ser bajarme.
What I wanted is to go all the way down and download the binary files up and down, and there you see the Tempest ID that has been allocated. And basically the only thing that needs to be done this is it. This is the binary. I'll just grant running permits and privileges. I'll run it.
Esto ahora mismo está transmitiendo en Morse.
This is now broadcasting Morse, the whole file with all variations, everything that I've said, and can be intercepted. Anyone can come in and intercept it. What's in it? Well, a few things. The receiver will be the only one that can get and receive right. So what does the receiver need to do? Well, we would get the signal, the messages, we would get it all. And next, for you to see, so that you understand what's being emitted, what's being broadcasted. I got this other one, and I've got this one that is for the receiver. So this here has produced this. So let's produce a file that is called Tempest MTX. Regularly you don't see it, but you see the search and replacements and standardization of the file. So there is no mystery to it. That is all. And this is what you are getting and what you're broadcasting. No problem here, because we've got all the time in the world, so I will broadcast it again and again and again. This file goes out. Tempest out. And here, run or invoking privileges. I do it step by step so that you follow. So, the other one is silent. So, if we were to place it on a device, this one's silent. But we need to follow it. This is... Can you hear it? There is noise, right? There is noise. And when we rebuild the signal, it is good, it is useful to have this noise. Plus, pity is we don't have someone speaking on the background, some broadcasting a station broadcasting, because they would all overlap, but then I get and filter it and I would get my own signal out. This is what I was saying. This has produce the file. Same here. It's not actually, because it actually fits in different things. So this is a file. Now, -6. What this Tempest does is, well, I could have uploaded it, and if we did understand it, this is what it's been broadcast. So it's all being broadcasted, right? That's what's been broadcasted. I get it back, and when I get it back, I see if it's 2 dots, I get 2 dots back. I get, I don't know, T, whatever, all of it. It is just the receptor, the receiver, sorry. And what do I need to do? I just need to get it, place it there, and it follows the same steps, reverse order, getting everything such as encryption keys, etc. And then finally, what do we find? It would be a file, the one we're interested in. The file we should have exfiltered out of this device, where we actually see here that we managed to take away whatever I say, slash, asterisk, several files, or whatever. So if it were intercepted in between, there is not much problem in it. What next? What do we want to do? Well, there are a few things that have been done, yes, but cannot be shared, I'm afraid. That would be a frequency that we could choose. We would also see what can broadcast and receive, because there's so much band noise that we want to filter. We want to see high power directional antennae, because I know that you're broadcasting from there and I get my antenna here just a few meters away. The radio set is just nearby, and so there is only limited space, and we know what's the problem with antennae. For example, if we want to start playing around with different filters to reduce noise, for example, with a software decoder that SDR, so as it goes in, it's filtered. We could also use it, the coders, encoders, and decoders. We can use something that is a bit more powerful. We could have a killover. When you're grabbing, I place the Tempest in, and every key you stroke, there's Morse transmission, or we can use a bad USB attack or whatever. So it seems that it's been confirmed that this Tempest does work. And since we are here at CyberCamp, I brought my own clip. I hope you like it. This is my choreography. These are the super trolls. No music, I'm afraid. So this is a joke. This is that, yes, it seems that Tempest has been confirmed. And now time for questions, if you have any. If you are willing to applaud, that would be welcome as well. If there are questions, I see nothing from here. I'm blinded here. I'm afraid I cannot hear you. So what if it were in a Faraday cage? It would not work, right? Actually, specs say that we need to use a Faraday cage, but what happens there? Well, yes, there's shielding, there's everything, but shielding, well, it's not that good. For CCI, it is more secure. It does much more than in any other outside gadgets we would use. Of course, there are agencies and people who say, yes, let's Trojanize it massively, all of it. Such as things that have been tracked down and there's been research, and maybe this been moved to Windows or Linux or anywhere. And even there's been some research on mobile phones to see to what extent mobile phones can broadcast this way, or emit this way. This would be quite simple. A visible side of the top of the iceberg, so to say. I don't know how it would work, but if you are talented enough, you can see that we can increase the speed, we can broadcast into quadrants, and so we would be broadcasting more things, and I leave it there. Some people are laughing their asses off here, by the way. A few questions here. I'm afraid they will not hear you. Carlos asks, maximum distance for listening in. A radio set as simple as this? A radio set as simple as this? You mean the villains? So cartoon agents with an antenna aiming, I don't know, 8 meters? It is broadcasting. But we know, they know better than us when it comes to SIGINT. They are very good at it. Distance, I don't know. I find myself here inside a Faraday cage without connection to anything, basically. We would exchange things by writing them on a piece of paper, and there you go. And we will meet for dinner at this time. Another question back there. Any test for file reception, not just to extract information? Yes, of course. And I say so because the receiver cannot bring it all with me, but there is a series of receivers that have a gadget similar to this one, and we just place a binary into a device and it's all dumped, and you get the files, no problem. It is not bidirectional, that's not. So far, I cannot grab from the receiver, turn it into a emitter or a broadcasting station, because it's about filtering information and we know what we want to get. Over here. No, not bidirectional, but can you reverse phases and you send something to the CPU? Well, it's way too risky. You could, since it is harmonic with a nearby device, yes, you can add some more scrap into the CPU and we could screw the transmission, but problem is with the device that it's a bit isolated. How do you get something in? That's hardware now, and those devices don't usually make it out to the street for a walk. I mean, CPU could interpret what do we send them. Yes, anyway, we would need first to understand what we want and try to add something to it, but it's going too fast. The tests so far prove that it's too fast and so we cannot interfere and get something visible out of it. It'll be done, for sure. It'll be done. Me too. Especially knowing you, I'm sure that the villains will manage. If there are no more questions, thank you for your participation here at CyberCamp, and see you later. Thank you very much.